Okay, 1a. So, we've got here exponential functions. Exponential functions. And so an exponential function, the basic exponential function is some number to the power of x. That's the basic exponential function. Alright? So we might have something like y equals 2 to the power of x, okay? Or terminology you're familiar with, f of x, the function with regards to x, is 2 to the power of x. They mean the same thing, don't they? And what is a function? Let's just like really backtrack. We're saying we've got some x value, x is 0, 1, 2, 3, and we've got some y value. Well, here, y is 2 to the power of x. So if we have 2 to the power of 0, 1, if we have 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, all right, and we could go ahead and solve all those coordinates, and we could plot them on a Cartesian plane, right? You know, you could go, x is 0, y is 1, x is 1, y is 2, x is 2, y is 4, x is 3, y is 8, all right, and you can plot the graph of it. That's how we would generate that, right? So that's the basic exponential function. And I've listed a number of dot points there about how we can manipulate it, all right? So I've got values of a, b, c, and d. And in chapter 1, we're going to be going over this again and again and again. So you have lots of exposure to it. A is what we call the dilation factor. Okay, so if we've got 2 to the power of x, and I put a number out the front, let's say, for instance, like in our first example, I put 3 there. What I'm doing is I'm multiplying every value by 3. So how would that change this table here? We would have, if I'm multiplying every value by 3, we would have 3, 6, 12, 24. Okay, what does that do to the graph? Well, all of a sudden that point's 3, and that point's 6, and that point's 12. It stretches it, it dilates it, it pushes it further away. So this is a dilation factor, stretches it further away from the x-axis. All right, so that's what A does. B is also a dilation factor. That's this number here. C and D are what we call the horizontal and vertical translations. So they're going to shift it to the left or to the right. So C shifts it left or right, and D shifts it up and down. Now, you're not really expected to know all this manually because you can rely on the calculator a fair bit. So hopefully that's pretty familiar too. Okay, so enough yet. Let's get into the very first question here, and let's try and answer all of them. So we have the function y equals 3 times 2 to the power of x take 1, take 5. All right? And it says, identify the values of a, b, c, and d, and describe the translations from the base 2 function. Now the base function, I've written right at the top, exponential functions take the form a times b to the power of x take c plus d. All right? And so we're comparing that with this to identify what is A, what is B, what is C, what is D. All right, so A corresponds with 3, so we're going to say A equals 3. What does the 3 do? It's the dilation factor. It stretches, there's lots of ways you can describe it, dilates the graph, stretches the graph further away from the x-axis. Okay, by a scale factor, by a factor of 3. Now I've got notoriously messy handwriting, especially when I get excited. So please, if you can't read anything, just ask me. I won't be offended. A is 3. Very good. Okay, what about B? B is 2. All right, B is 2. And that's the base of our function. It's an exponential function. All right, remember with exponents, we have the base and the power. We have the base and the index. Okay, C is horizontal translation. So what corresponds with C? 1. C is 1. All right. It's not -1 because the form of the function is x take C, and here we have x take 1. So what's C? 1. And 1, x take 1 means it shifts it 1 unit right. Okay. So here's a rule. This is going to pop up again, but x take C shifts C units right. Oop, that doesn't look very good. C units right. X plus C, C units left. All right, so it's sort of opposite to what you think, right? If we have X takes C, shifts the function to the right, it picks it up and moves it over. And if we have X plus C, it's going to pick it up and move it over that way, however many the value of C is. All right, so we've got X takes C, shifts 1 unit left. And then we have D is -5, okay? D corresponds with -5. All right, this time we include the negative because we've got plus D here, and then we've got -5 there. So you need to have -5, and that shifts the whole thing down 5 units. Okay, very good. All right, state the domain and range. So there's 2 ways we can do this. What's domain, what is range? We're talking about what are the possible values the function can have. So a simple way is to graph the function, right? You can look at the function and you can determine from the graph what's its domain, what's its range. However, for an exponential function, we've got 2 dot points there. We've got x is greater than d, for domain, XER, x could be any real number. It exists both ways to infinity for x. All right, that's always going to be the case. So for our domain, XER, that's just one of the properties of exponential functions. It's our 5th dot point there, so that one's going to be true. And then we've got the range. All right, our range, and our range is our possible values of y. And we're going to have either it's larger than D or less than D. What is D? So let's look at the 2 possible things. I'm going to just write them down. Actually, let's talk about what is D first. D is this D here. D corresponds with -5. Okay, so we've got y is either larger than -5 or y is less than -5. Okay, so that's the last dot point. That's where I've got that from. And there is a typo, it says x greater than d or x less than d. When we're talking about range, we're talking about y, yeah, possible values of y. So y is either greater than -5 or y is less than -5. They're the 2 options, but we've got to decide which one is it. Okay, now from here, again, we can look at our graph to inform this decision, but we can also use the properties of A and B. They dictate the shape of the graph. In our circumstance, we've got A is 3 and B is 2. Both A and B are greater than 0. Okay, so if we're looking along here, which shape does that correspond with? A and B are both positive, they're both greater than 0. It's the first one. All right, A is 3, B is 2. That satisfies the first statement. So our function, even though we haven't graphed it yet, we know it's going to have this shape. It's going like this, which means this is where the asymptote is. Okay? What's the asymptote? All right, we've got the, again, look at our thing. The last one, D is the vertical translation, and Y equals D is the horizontal asymptote. So the equation of this line is Y equals -5. Right, so we've already got a rough idea of what the graph is going to look like without having graphed it. Okay, we can determine all of that information from the dot points we've got here. There's the asymptote. We can see the arrows, it's going forever. Okay, it's going that way forever and this way forever, and it exists above -5. So therefore, the domain, x is any real number, XER, everyone familiar with this terminology? That's my assumption. Okay, if you're not, please let me know. And then for the range, well, y has to be greater than -5. That's what we've determined because of the shape. It can't be less than -5, it doesn't exist there. It has to be greater than -5. So I said before, it's going to be one or the other, and we determined it has this shape, so it has to be this one. Very good. Okay, next we're on to a graph. Now this is good because I can talk about what's going to earn you 4 marks for a graph in one of your tests. So we're going to use our calculators here, so please pull your calculator out. And I might go grab another whiteboard while you're up here. Please sketch the function in your calculator and observe the properties that we've illustrated.
What are we doing? What are we doing? Yeah. Yeah.
What's our code? 85.
Just see. This whole discussion. You're wasting your time.
All right. So I've got an old version of the calculator, so it doesn't pop up in colour. I'm going to try and fix that. But let's sketch the graph from what we've got here. So you might have typed it all in. All right. So if I just press exit, we've got 3 times 2 to the power of x take 1, take 5. I have to write it in differently because it doesn't. It's very painful, the old version. Okay. So we've got it written there, and we press execute. I hope we're pretty comfortable with these graphing processes. Now the first thing we need to do is set our V window correctly. Now a lot of the time we'll be able to just get away with the standard setting. So V window is F3. I'm going to press that, and that brings up the constraints of my Cartesian plane. If you think, here's the Cartesian plane, you've got a window over which you're looking at. That's your V window, your virtual window. X min is the minimum value of X that you're looking at the Cartesian plane. X max, Y min, Y max. You're restricting where you're looking at it. Now, to start with, I just go V window and set it to STD. That's standard V window, and that goes from -10 to 10 for both X and Y. All right, that should allow you to see most graphs. Sometimes you need to juggle it around a bit. All right, and then you press execute twice. There is our function. All right, so I'm going to provide a rough sketch of it by getting some of these numbers. So maybe we do have to find the x-intercept, find the y-intercept here. We do have to answer that a little bit later. So the first thing we know is we have an asymptote at y is -5, okay? Now, we know that from our notes. There's another way we can see that as well, which is just by tracing along it. F1, trace, you can trace along the function. And if we go further and further this way, look at the y value, -4.8, -4.9, -4.967, -4. It's getting closer and closer and closer and closer to -5, although it will never ever reach -5. That's what an asymptote is. It's an invisible line that it can't pass. It gets closer and closer and closer, never touches, never crosses -5. All right? That's why we say, and we've got the graph of it, that's why we say y is greater than -5. It doesn't exist at -5, it exists for all values of y larger than -5. So from there, all the way up to infinity. And our range, you can see these arrows indicate it's going in both directions forever. Okay, so for the graph, let's just leave it as a rough sketch for now, and we'll come back and fill in some of the other components in a moment. Okay. Determine the value of the function to 3SF, that means 3 significant figures, when x equals 3. So we want to know when x is 3, what is the value of the function? So, the fastest way to do this is when you're tracing along it, okay? So if you press F1 for trace, and you just press the number 3, enter x value, it's going to take you straight there. I want to know what's the y value. When x is 3, we've got y is 7. Okay, when x is 3, y is 7. All right, that shouldn't shock us, because let me show you why else we know that is true. We're going to make lots of connections. What's it? 3 times 2 to the x take 1, take 5. This is our function, and we're saying, what is the y value when x is 3? All I'm doing is putting the number 3 where the x is. Okay, and then we're going to process that. using bed maths, we have to do that one first. We have 3 times 2 to the power of 2, take 5. All right, so we're doing the exponent first, and now we're going to activate the exponent. So we have 3 times 2 squared, 3 times 4 take 5, 3 times 4 is 12, 12 take 5 is 7. Okay, so we expected that to be the case. We've got the x value and we can process it. Here we've done it manually, or we can use our calculator. When x is 3, what's the value of y? 7, just from tracing that out. So there's our answer to part D. Part E, find the x-intercept using technology. So x-intercept, roots, zeros, they all mean the same thing. So we're going to go into G-solve, which is F5, and we have root. There is only one x-intercept. What's the x-intercept? Where it crosses the x-axis. And we've got 1.736. So that was my answer to D. Here's my answer to E. 1.736. X-intercept, 1.736. Now, I've written there 4 significant figures, and I'm going to get you guys in the habit of doing this. I always do this. I always write 4 figures and then round in my next step. Okay? All right, round it to 3, round it to the nearest. Okay, so that was E. So then let's go to F. Find the value of x when y is 2.3. So now we get to use a different strategy. We're not saying what's the y value, we're saying what is the x value given a particular y value. So you can think about it on the graph, here's our x-axis, here's our y-axis, and we're saying when y is 2.3, what's this value of x? What does it correspond with? What's this value of x when y is 2.3? Here there's some set of coordinates, the y is 2.3, what's that value of x? And so again in G-solve, alright, so we'll go back to F5, G-solve, and we're going to press the across arrow, because that doesn't bring up all of our options. Alright, there we've got the root, where it crosses the x-axis, maximum and minimum points, the y-intercept, where it crosses the y-axis, intersection, so that's when we have multiple functions on the graph, when do they intersect? Next one, we've got y-calc and we've got x-calc, okay. What are we calculating here? Determine the x value. We're doing an x-calc. Alright, so that corresponds with F2. What is the y value? The y value is 2.3. So we just type in 2.3 and it's going to give us the corresponding x value, 2.282. So we can write that out. When y is 2.3, x equals 2.282. Okay, 4 figures, and then state to 3, 2.28. All right, now that we've gone and got some of this information, we're ready to put it in the graph a bit more. So we know that the coordinates of this point, when y is 2.3, x is 2.28, almost 2.3 as well. We also know that the x-intercept is 1.74. We didn't find the y-intercept. I'll do that quickly. Minus 3.5. All right. How can we confirm that? Okay, we can G-solve on our calculator. Y-intercept. The y-intercept occurs when, what's the x value here? 0. X is 0. So if we were to repeat, where's my eraser? Excuse my finger. If we were to repeat this process here, here's the function, right? We're saying when x is 0, what's the value of y? So we're going to have 3 times 2 to the minus 1. And 2 to the minus 1, that's a half. That's the same as half. Let's explain why. We're going to be recapping lots of this stuff. 2 to the minus 1. Okay? That is the same as 1 on top of 2 to the power of 1. Okay, that's index laws. What is 1 on top of 2? That's half. Okay? So 2 to the minus 1 is the same as a half. So here we have 3 times a half. 3 times a half, that's 3 on 2. That's 1.5. So then we have 1.5 take away 5, 1.5 take away 5, and that's how we got negative 3.5. Okay, so we can determine it manually, we can determine it from our calculator. Now, that's all we're going through today, isn't it? So let's just jump back across here. We had a quick introduction and revision of functions. We talked about B window. A, B, C, D, okay? We're going to be going over this again and again and again. And it's particularly well demonstrated when we're doing trigonometry. When we look at trigonometric functions, which we do in 1D. That's when it's best exemplified in my eyes. So I don't want you to be alarmed if you're sort of a little bit confused or haven't got a full grasp of this yet. What we're doing today is just a lot of calculator work. We're going to be doing a lot of G solving, we're going to be doing a lot of graphing, and making ourselves familiar with the process, with technology. But where you can, try and think about how could I do this process manually? Can I find the y-intercept easily? Can I find the corresponding y value given a certain x value? So excellent, so that's enough to get through 1A. This is questions 1 to 6. So let's get started on that. That's what we're going to do today.
I don't know if you're dropping down into we might be doing
Oh, are you? Yeah, both of you.
Yeah.
Ah, okay. Oh.
That's why we're not doing it.
But you're not doing it, when are you doing it?